2.5 times the size of Earth and 700 trillion miles away, and it could be home to living organisms.
For decades, astronomers have been hunting for a mysterious object lurking at the edge of our solar system, an unseen giant that could be warping the orbits of distant icy bodies beyond Neptune. It's known as Planet 9, a theoretical world that could be 5 to 10 times the mass of Earth, and possibly orbiting the Sun from a distance so vast that a single year could last tens of thousands of Earth years. But despite numerous calculations and simulations, no telescope has ever definitively seen it, until now. Or at least, that's what a powerful new artificial intelligence developed by NASA might be suggesting. Because buried deep within the massive datasets captured by the James Webb Space Telescope, NASA's AI system may have found subtle yet compelling hints that Planet 9 could be more than just a theory. This discovery didn't happen overnight. The concept of Planet 9 dates back to 2016, when Caltech researchers noticed a strange clustering in the orbits of several trans-Neptunian objects, or TNOs. These distant bodies moved in a way that defied expectations, almost as if an invisible gravitational hand was tugging at them. The only logical explanation, they said, was a massive planet far beyond Pluto, too dark and too distant to be seen with current technology. It was an exciting hypothesis, but for years it remained just that. A hypothesis. Observatories scanned the sky. Supercomputers ran simulations. But the elusive planet refused to show itself. Enter the James Webb Space Telescope. Launched in December 2021, Webb is the most powerful space observatory ever built, designed to see further and more clearly into the cosmos than any telescope before it. Its infrared instruments can detect the faint heat signatures of distant objects, precisely the kind of tool needed to hunt for a cold, faraway planet. But Webb produces massive amounts of data, far more than any human team could reasonably sift through. That's where NASA's AI comes in. Using advanced machine learning algorithms, the AI was trained to search through petabytes of Webb data, focusing on anomalies in the Kuiper Belt and beyond. Instead of looking for direct images of Planet 9, the AI was taught to find patterns, gravitational influences, minute movements of background stars, and small discrepancies in predicted orbits of known bodies. These are the kinds of clues that might suggest a massive object is lurking in the shadows, distorting the region around it. And in early 2025, something incredible happened. The AI flagged a series of data points as highly anomalous. They weren't errors. They weren't cosmic noise. They were consistent gravitational signatures, observed at multiple time intervals across different Webb observations. The pattern matched what you'd expect if a super-Earth-sized planet were passing through a particular section of space. For the first time, scientists had not just a theory, but a target. This region of interest lies in the direction of the constellation Cetus. According to the AI's analysis, the potential Planet 9 would be orbiting the Sun at a staggering distance of between 400 to 600 astronomical units, meaning it's 400 to 600 times further away from the Sun than Earth is. At that range, sunlight is incredibly weak, and any reflected light from the planet would be nearly undetectable. But heat? Even a frozen planet emits a small amount of infrared radiation, and Webb sensors are just sensitive enough to pick up that heat if you know exactly where to look. Follow-up observations are already underway. NASA and several international observatories are now pointing their most advanced telescopes toward the region identified by the AI. What's fascinating is that even the motion of nearby Kuiper Belt objects seems to subtly shift in a way that suggests a massive object is influencing their orbits. These are indirect signs, yes, but they're stacking up. And if confirmed, we might be on the verge of discovering a new member of our solar system, one that rewrites our understanding of planetary formation and dynamics. But what makes Planet 9 so special? Why is there so much excitement around it? For starters, it challenges our models of how the solar system evolved. If Planet 9 exists, it likely didn't form where it is now. At such an extreme distance from the Sun, there wouldn't have been enough material to form a planet that massive. That means it might have formed closer in and was later flung outward by a gravitational interaction, possibly with Jupiter or Saturn. Or even more intriguingly, it might not be native to our solar system at all. Some scientists speculate that Planet 9 could be a captured rogue planet, a free-floating body that wandered into the sun's gravitational grip billions of years ago. And the implications don't stop there. If there's a super-Earth in the outer solar system, it could host a moon system of its own. It could even have an atmosphere, albeit a thin and frigid one. It could tell us volumes about the types of planets that form in other star systems, especially since super-Earths are among the most common types of exoplanets we've found so far. Strangely, we don't have one in our inner solar system, until now maybe. The AI's role in this discovery is perhaps just as fascinating as the planet itself. This isn't just a tool scanning numbers. This AI is capable of pattern recognition at a level beyond human ability. It doesn't just find dots, it finds meaning in the noise. Trained on years of astronomical data, it understands what a gravitational anomaly looks like, how a stellar background should behave, and how the presence of an unseen object can warp the light paths in ways too subtle for the human eye to notice. It's a revolutionary approach to astronomy, one that could become the norm in years to come. Before Webb and AI, we relied heavily on light-based detection, seeing planets through telescopes or spotting dips in starlight as a planet transits its star. But in the distant reaches of the solar system, those methods fail. Planet 9 doesn't transit a star, it doesn't shine. But it leaves fingerprints, and NASA's AI is trained to find them. Think of it like cosmic forensics, piecing together a mystery not from direct sightings, but from the echoes and shadows it casts across space. Even if Planet 9 turns out to be something else, a swarm of smaller objects, a primordial black hole, or a misinterpretation of orbital dynamics, the process itself is a monumental achievement. It shows that with the right tools, we can explore the farthest corners of our solar system, even when direct imaging is nearly impossible. And if Planet 9 is real, its discovery will mark one of the most important astronomical breakthroughs of the 21st century. With the AI's discovery setting the stage, NASA has now shifted from detection to confirmation. The next step involves the most advanced observatories on Earth turning their gaze toward the AI-identified region in the constellation Cetus. Telescopes in Chile, Hawaii, and Spain are collaborating to conduct deep sky surveys with a singular purpose: to catch a faint, consistent motion, a slow drift across the backdrop of stars. If an object is truly orbiting our sun at the vast distances suggested, it would reveal itself not through brightness, but through movement. Even the slightest shift over days or weeks could confirm the presence of a new planet. What's especially remarkable is that the AI didn't just pinpoint a new target. It also reanalyzed older datasets from ground-based telescopes and earlier space missions like WISE and Spitzer. Some of these records, dismissed as inconclusive or irrelevant in the past, now appear to contain subtle anomalies aligning perfectly with the gravitational signals Webb has observed. When viewed through the AI's refined lens, these old pieces of data snap into focus like parts of a long-lost puzzle, helping researchers retrace the object's probable orbit and motion. While the simplest explanation is a super-Earth-sized planet, not everyone agrees on what exactly the AI found. Some scientists suggest an alternative hypothesis, a loose cluster of icy bodies bound together by gravity, giving the appearance of a single massive object. If true, this discovery would still be groundbreaking. It would mean that our solar system harbors a region of clustered mass far beyond Pluto, that we've never seen or understood before. Then there's the most exotic idea, one that keeps resurfacing despite its incredible implications. What if this isn't a planet at all? What if it's a primordial black hole? This hypothetical object would be smaller than a marble, but pack several Earth masses into its core, a remnant from the very beginning of the universe. It wouldn't emit light, it wouldn't reflect it either, but its gravitational influence would be unmistakable. And now, with improvements in gravitational lensing and high-precision tracking, astronomers are beginning to test this wild possibility. Though speculative, the fact that we are even entertaining such a notion shows how little we truly know about our own solar system. But regardless of what Planet 9 turns out to be, this moment marks a shift in how we explore the cosmos. For all our spacecraft and satellites, we've mapped less than 1% of the Kuiper Belt and virtually nothing of the even more distant Oort cloud. These regions are frozen archives of the early solar system, filled with objects and mysteries untouched since the sun first ignited. Planet 9 could be just the beginning, Its discovery would confirm that the outer solar system is not empty, but filled with invisible giants hiding in the dark. Already, discussions are underway about how to send a spacecraft to investigate. Engineers at NASA's Jet Propulsion Laboratory are sketching designs for long-range probes, some using ion propulsion, others nuclear-powered, that could one day visit this mysterious world. Though it could take decades to reach its destination, even a flyby mission could transform our understanding of planetary science. With a confirmed target, mission planning could begin within years. Imagine the first close-up images of a world that has never seen sunlight in any meaningful way. A frozen colossus drifting silently at the edge of the sun's kingdom. The cultural impact would be just as immense as the scientific one. A new planet in our solar system would shake up everything, from school textbooks to space policy. It would capture public imagination just like Pluto once did, or like the first images of Mars or the Moon. For an entire generation, Planet 9 would become a symbol of curiosity and cosmic wonder. The ninth planet would no longer be a ghost in the equations. It would be real, with a name, a mass, a location, and a history. And then there's the AI, the unsung hero of this unfolding story. Its contribution cannot be overstated. This machine doesn't just run calculations. It learns, adapts, and finds connections no human brain could ever keep track of. It sees not only what is present in the data, but what should be there and isn't. It questions gaps, identifies outliers, and constantly updates its understanding as more data flows in. It's not just a tool, it's a partner in discovery. And this may be the new frontier in astronomy, a collaboration between human intuition and artificial intelligence that opens doors we didn't even know existed. This AI isn't limited to Planet 9 either. NASA is already using versions of it to search for exoplanets, detect signals from distant galaxies, and study supernovae before they erupt. What we're seeing is the rise of a new kind of science, one where machines don't just analyze the universe, they help us interpret it, predict it, and maybe one day even explore it with us. As of now, Planet 9 remains unconfirmed, but the weight of evidence is growing. The region of interest is being scanned at multiple wavelengths. Infrared anomalies are being cataloged. Motion tracking is underway. Each new observation brings us closer to either confirming a ninth planet or rewriting our models to explain what else could be producing these gravitational signatures. Either outcome would be historic. Either outcome would deepen our understanding of the solar system we call home. And here's the final, awe-inspiring thought. If Planet 9 is real, and we find it, it would mean that our solar system still has room to surprise us, that we are not done discovering the world around us, that even now, in an era of space telescopes and Mars rovers, there are still unseen giants in the dark, waiting for us to notice them. In a way, the search for Planet 9 reminds us why we look up at all. It's not just about the science, it's about wonder, about mystery, about the quiet, thrilling truth that the universe is vast and old and filled with things we have yet to imagine. And sometimes, all it takes to uncover those secrets is a little light from the farthest star, a whisper of gravity from an unseen object, and a machine smart enough to listen.